In this module, we'll try to understand the current landscape of attacks for operation technology. And the answer is not obvious or clear because companies don't easily share that information. Besides the high-profile cases we know, like Stuxnet that we discussed in previous modules, companies don't disclose exactly the cyber attacks that affect them, and it's very hard to find information online about it. However, there are a few things we can safely conclude by reading reports and news articles online. The first one is the fact that operational technology security is a global problem. It doesn't only affect the powerhouses. It's not unique, for example, the United States or China or Russia. Actually affects, as you can see on the map here, on the bottom right side, it shows the geographical distribution of attacks on ICS in the first quarter of 2020. And as you can see, the number of computers affected, they are all over the world. And this map here shows that every country should have some kind of a plan for cybersecurity for operation technology. The second piece of data that we can collect is the number of incidents. That's also difficult to find. Again, for the same reasons I mentioned before, these are not publicized. We don't have the exact numbers. Up to 2016, US ICS CERT was publishing incidents by sector, but they have stopped with the 2016 report. But till then, we could see the increasing trend in the number of incidents. In this pie chart, on the right side, you can see the number of incidents per sector. Critical manufacturing had the most attacks in 2015, followed by the energy sector with 46 incidents, water 25, transportation system 23, and the rest had less incidents. And again, these are the ones that were reported. We expect them to be actually many more. But in 2015, compared to the previous years, the incidents increased by 20%, and we expect this trend to hold for the years after. So even though we don't know the exact numbers, we do expect that cyber attacks actually keep increasing in critical infrastructure. Something we can definitely know, though, is the number of vulnerabilities, right? So before I talked about incidents. Incident means that some industry was affected by cyber attack, it was reported, and it appeared in a report. Vulnerability means that some of the devices, some of these controllers that we have briefly discussed, they have some kind of a problem that can be exploited in order to have some kind of a cyber attack. Here you can see on the bottom right, these are the reported vulnerabilities for a week, the week of January 21st to January 28th, 2021. And as you can see here, even within a week, there are quite a few vulnerabilities discovered, right? Rockwell Automation, Mitsubishi, Delta, Honeywell, Wago, all sorts of vendors, they have published vulnerabilities. Again, vulnerability, for example, could be a buffer overflow or hard-coded credentials, right? That it's something that is being recognized as an exploitation vector, and these vulnerabilities here also refer to either a patch, a firmware upgrade that you need to do to the devices in order to fix the problem, or some kind of a generic security methodology you need to apply, for example, not give access to unauthorized users for the devices in order to mitigate the vulnerability. So these are exact numbers we can see, and if you look at the graph on the bottom, on the top right, we see the vulnerabilities reported from 2017 to 2019, and you see a constant increase in the number of vulnerabilities. So in 2017, there are around 350, more than 400 in 2018, closer to 500 2019. And these are newly discovered vulnerabilities. Newly discovered means that they were discovered this year, and it doesn't mean they are the previous ones, right? So you can think of them as compound vulnerabilities. So if you haven't fixed the vulnerabilities of 2019, you have those 400 plus the 500 of 2019, that would be 900 to take care of. And this is a very important point because, as we will see later in this class, the patching industrial control system is not an easy task. You cannot take them offline easily, do an update and put them back. because outages typically have to be planned for days or weeks in advance. So the vulnerability increase is important, but you also have to think of them as compound vulnerabilities that they keep increasing, and we have the outcome of this, the conclusion of this, is that we cannot ignore them. They keep increasing, and they will keep increasing for the years to come. So companies need some kind of a plan to address these problems, right? Both the incidents, the increasing number of incidents and vulnerabilities. However, a recent survey for asking companies about their OT plans, the Operation Technology Attack Plan, revealed that actually most companies are not very well prepared for operation technology attacks. As you can see the numbers on the screen, 3/4 of organizations completely lack operation technology risk assessment, focusing your risk assessment on the operation technology. They don't have OT-specific security policies, and they don't have operation technology-specific security incident response plan. In other words, actually most companies are not prepared for cyber attacks that will affect their operational technology environment. Lack of preparation is also evident in when we look at the responses of the companies to cyber attacks. So in this slide, we're presenting the attack discovery process, and you can see the compromise moment in time. So before the compromise, here the graph discusses how much time it took to actually have the compromise, and then is followed by when was the compromise discovered. So as we can see here, 87% of the compromises took minutes or less. So the attackers didn't have to spend much time in order to compromise the system and enter to have some kind of access to it. However, after the compromise, we can see that most of the compromises were undiscovered for months. As you can see here on the right side, 68% of the attacks were not discovered until many months have passed. And this is another evidence of the lack of preparation of companies in cyber attacks. Only 3% are discovered quickly, within minutes, and most of them are going undiscovered for months. So we have a lot of expertise from the IT world, right? There are many solutions in the IT world that we can employ, and we have been successfully, for example, detecting malware with antiviruses, or having firewalls in our operating systems, and many other security mechanisms, authentication, signatures, certificates. So the first question to ask, right, when we think about defending in operation technology, can we just take the solutions we know and apply them to the OT world? And the answer is no, we cannot just do it. OT itself has many different characteristics and properties that require the security experts to focus on OT-specific solution. There will be a dedicated module on that. Here I just want to motivate a bit some differences in order to make us understand that just porting solution is not an acceptable approach to the problem. For example, ICS are generally real-time, right? The industrial control systems are real-time systems. They have a specific control loop frequency. For example, they pull the sensors every 5 milliseconds. They have their own control logic, and then they actuate based on what the controller is giving out as a result. And if you have a computer that has to respond in 5 milliseconds, any other process running in the computer may affect this determinism in the timing, right? So for example, if you have to install on a PLC antivirus solution, that would take CPU time, and that means it may violate the real-time requirements of the PLC. So adding, for example, an antivirus in an industrial computer may not be a good solution, because it can it can create problems with the real-time requirements. Another important thing is availability. IT focuses a lot on confidentiality to make sure that our data stays private, also stays on focus on integrity, and that means that we have to make sure that our data is not modified in an unwanted way. and OT is much more focused on availability because there's not much confidential data going back and forth in the network, but there is a need for availability. There is a need for responsiveness between the systems. And many of these ICS processes are continuous in nature. They work continuously with nanosecond, millisecond, second frequency, so they cannot be disrupted. And in order to disrupt them, you have to plan in advance. Even though these outages, we see them in the IT world, right? Sometimes you want to access a service and you get a message that we apologize, but the service will be available for an upgrade those 2 hours on Saturday or some other day. But with plants, when you talk about a nuclear plant, you can't just turn it off in a second, right? You may plan some maintenance, but these outages should be planned weeks or months in advance to ensure that there's no damage in the equipment, and also there's no interruption in the actual process and the outcome of the process. If it's a power plant, you have to ensure that the city has proper power generation to ensure that there won't be any blackouts. So this is important here because we kind of got used to in the IT world to be updating our computers, right? We get a message from Windows, you want to update your computer. Well, many times we click postpone because we don't want to do it and we're annoyed by the message, but at some point we do. And Windows make it more and more difficult for you to avoid the updates because it is critical to actually apply the patches to make sure that the vulnerabilities cannot be exploited, whatever the patch is actually doing to our computers. But in the ICS world, you cannot be restarting your process every night, right, or every week. So in order to apply patches, we saw vulnerabilities before. Remember the graph that showed that we have many vulnerabilities. To fix them, you have to apply a patch. To apply a patch, you have to probably restart your system. So applying patches regularly may not be an option compared to IT, that every Tuesday we apply a patch. We have to think, we have to have a proper plan in place in order to make sure our security solutions are up to date. Besides the increasing number of vulnerabilities and incidents that we see in OT security and make the problem a very actually important problem, there's a number of approaches in the industry that actually make the problem even worse. I call them security myths, and I'd like to discuss them here in this section in order to understand how bad the situation is. So the first myth that we hear a lot is that the idea of the air gap. And as you can see on the right side, air gap means there's no connection between the OT and the IT environment, right? Even though we discussed the IoT, IT-OT convergence and the fact that these levels are now bridged and there is information flow between the two, in the past, and maybe some maintain this as also a security solution, is not to connect the two, and they say that air gap means there's no digital connection, right? So there's no way you can go from the enterprise network to the industry network because there's no physical connection, there's no cable connecting those two. So this can be, for example, another building that has no access to the internet, and this is another building that has access to the internet, and there's no wires connecting the two. So as a common security, the air gap is a very common security approach, and many people claim that we don't need any security in the OT environment because it's air gapped. There's no connection to the outer world. That's a myth because, as reported by the Department of Homeland Security in some of the assessments they did, they found that there was never a case that the operation network was completely separate from the enterprise network. Actually, they reported a few numbers. For example, on average, they found 11 direct connections between the two. And in some extreme conditions, they found up to 250 connections, right? And these are cases that there was a claim there's no connection between OT and IT. And these connections may not be apparent, right? If you take your mobile phone with you, the phone may be connected to a network outside, right? If you have a data connection with your cell phone provider, then you may be in the OT environment, but your phone is connected to 4G, and then this 4G, you could have connected to your enterprise network through VPN. So now there is some form of connection between OT and IT. So one thing to keep in mind, even if you think you have a an air gap and there's no connection to the OT world, you still have to introduce proper security controls, assuming there could be a connection to the OT that you're not aware of. A second myth is about use of proprietary systems and protocols. And there's this idea, a notion that the attackers don't understand them because they are unique to the companies and they're not public knowledge. It's more of an approach of security by obscurity. So the fact that there's no information online means the attacker cannot attack. And security by obscurity, for those of you who have taken information security before, no, it's a terrible idea. The fact that you can use it as a complementary mechanism for, right, not to publicize information, but completely relying on obscurity for your security is a very bad idea. So, and to prove how bad this is, especially in this context, there was a report recently that reviewed a few applications, and they actually found out that the proprietary applications, the ones actually built by the vendors, they have a lot of open source components. For example, you can include OpenSSL or an Apache server. These are open source projects, and the vendor does not want to reinvent the way you connect through SSH, right? They can take OpenSSL and then they can import it to their software and use it. And actually, most applications do that. They contain an open source component to an extent or another. So it may be proprietary on the shell, but inside it includes components we know and understand, like again, Apache and OpenSSL. And not only there was a lot of open source, most of them, 78% of the code bases had at least one vulnerability. So having proprietary software from a vendor doesn't mean you're protected. Within the software, again, there could be something open source, and maybe we already know how to attack older versions of these open source systems. From the recent attack I mentioned briefly before in Saudi Arabia, in the petrochemical plant, this attack targeted Schneider Electric components. And by the speed of the attack and how fast it went through the system, it was obvious that the attack had been tested on a similar setup using real Schneider Electric equipment. So this claim that they don't understand because everything is vendor specific is wrong, and we have to always keep in mind that if the attacker wants, they'll find a way to attack besides, even if the systems are proprietary, both the systems and the protocols used. The third security myth is about the existence of the firewall. A firewall is a very good mechanism for blocking traffic flowing through the networks, right? So, this air gap we discussed and this IoT-OT convergence, you can connect IT to the OT for all the benefits we discussed before if you properly have some kind of a firewall between the two networks. So if something happens in the enterprise network and you get infected by malware, it won't easily propagate to the industrial part because it will be blocked by the firewall. But a firewall it shouldn't just exist, right? A firewall is as good as its configuration. So if you don't configure the firewall properly, it's not a proper security mechanism. So let's look at some these graphs here by Verizon. So in the latest data breach investigation report, Verizon first, they tried to find what are the ways that a system gets breached, gets attacked. And if you see here, from 2015, this yellow bar, the error bar, keeps increasing, right? So error refers to ways that a system has not been configured properly because of a human error on some site. So the error component keeps increasing. And if we break down the error, so on the right side, this graph breaks down the error component, right? What are the different errors that we have here? We see that misconfiguration is a major one, and that also it keeps increasing the last few years, right? So, and now it's the dominant one. So misconfiguration means that I set up my firewall, but I didn't configure it properly. For example, I forgot to block traffic on some ports. I forgot to add some IPs to deny list or to allow list. The way I've set up my components is not correct, and this allowed information and traffic to flow between different networks. So again, it's important to emphasize and understand that a firewall by itself is not enough, right? It's all about appropriate configuration. And with this, we conclude this section. I try to motivate the situation, how bad it is, the current landscape. Attacks keep increasing, vulnerabilities keep increasing, and the problem is getting worse also because of some security policies that are not appropriate for the current landscape.